Hi everyone. In this section we can discuss about the flange coupling problem. I can read the question. Please write. Design a cast iron flange coupling to transmit 18 kW at 1440 RPM. The allowable stresses for shafts, keys and bolts are 75 MPa in shear, 150 MPa in crushing. The allowable shear stress for cast iron flange is 5 MPa. So in this question they are clearly given the power and the speed of the shaft. Also they given the stresses for the shaft, keys and bolts in shear and crushing. Now we can go for the design. First one, design for shaft. Here the given parameter we can write it as P is equal to 18 kW, N is equal to, that is the speed, that is equal to 1440 RPM, tau S, or we can denote it as tau 1 or it is tau B, all are 75 MPa, that is shear. Then sigma B, sigma B1 we can write it as 150 MPa. Then tau C, that is for the flange, it is 5 MPa. Now we can design the shaft. From the equation, T is equal to 9.55 into 10 raised to 6 P divided by N. That is from the data book, page number 50, equation number 3.3. If we substitute the value of P and N in this equation, we will get the value of T. That is equal to 119.38 into 10 raised to 3 Newton millimeter. Next one, we can find the value of diameter. We know that equation tau is equal to 16T divided by pi d cube. We will get this equation from page number 50 data book and equation number 3.1. If we substitute all other values except D, we can find the value of D, that is equal to 20.08. So we can standardize the diameter of the shaft from the table 3.5a, page number 557 from our data book. That is D is equal to 22 mm. That is for the design of shaft. Next we can design for a hub. From the data book, page number 252, equation number 13.1D, hub diameter D1 is equal to 1.5D plus 25 mm. If we substitute the value of D in this equation, we will get D1 is equal to 58 mm. Then next we can find the value of hub length. What is that value? From the table, from the equation 13.1, page number 252, 13.1G, equation is equal to, equation for the hub length L is equal to 1.2D plus 20 mm. If we substitute the value of D here, then we will get the length. Next we can design for the key. How we can find the key? It is on the chapter 4 on the table, on the data book. So take the page number 69 and table 4.1. We can find D is equal to, for a value of D is equal to 22 mm, the value of B and H are 6 mm. Then next we can go for the length, it is already taken, that is equal to 48 mm. Then next we can check for the stress. How we can check the stress? Equation number 4.5a, page number 62, we know that T is equal to 1 by 2 tau 1 LBD. We know all the values except tau 1. We will get tau 1 is equal to 37.68. That value is less than 75 MPa, hence that is in the given section. Hence our design parameter for the diameter and length are safe. Next we can check for the crushing. Again page number 62, equation number 4.4b, T is equal to 1 by 4 into sigma B1 LHD. If we substitute all other values except sigma B1, we will get the value is equal to 75.37, which is also less than the given data. Given value is 150 MPa. So again the design is safe. Next we can go for the design of bolt. It is given in the chapter 13 in our data book, or page number 251. There is an equation 13.1a. I is equal to 3D divided by 80 plus 2. That is for the number of bolts. That is equal to 8.42. We have to consider the next even higher value, that is equal to 4. So we can supply 4 number of bolts in the particular flange. Next, the diameter of the bolt. How will you find the diameter of the bolt? It is obtained from the page number 251, equation number 30.1c. D is equal to 0.423d divided by root I plus 7.5 mm. We know that I we already calculated from the just above this equation, that is equal to 4, and D already we calculated. If we substitute these values, we will get small letter d, that is equal to 12.15 mm. We have to standardize the bolt diameter, that is equal to 14 mm. Next one, pitch circle diameter of the bolt. How we will find the pitch circle diameter? Again, it is already given in the data book, page number 252, equation number 13.1e. That is equal to d2 is equal to d1 plus 3.2d is equal to d1 we already calculated, and we already know about the small letter a, that is the diameter of the bolt. If we substitute these values, we will get the value of d2, that is equal to 102.8, approximate higher round of value, that is equal to 105. Now we can check for the stress. Again, page number 252, equation number 13.2c, they are given T is equal to tau b pi I d square into d2 divided by 8. If we substitute all the values in this equation except tau b, that is the shear, we can find the value of tau b, that is equal to 3.69 megapascal, which is less than the given data in our question. Now we can design for the flange. Again, page number 252, equation number 13.1f. The outside diameter of flange d3 is equal to d1 plus 6d. Here all the values except d3 we all calculated, so we can find the value of d3, and we have to approximate into higher value. Next, the thickness of the flange. Again, equation number 13.1h, page number 252. T is equal to 0.35 d into d plus 9. We will get it as 17 mm. Then we can check for the stress. The shear stress we can check using the equation 13.2e, page number 252. T is equal to tau c pi d1 square t divided by 2. If we substitute all the values except tau c, we will get it is equal to 1.33 megapascal. Now check from the question, that is equal to that is the value is less than the given value. Now it is also safe. Then next section, crushing stress, that is T is equal to sigma b I t d d2 divided by 2. Again, equation number 13.2d, page number 252. If we substitute sigma b except, then we will get it is 2.39, which is much more lesser than the given value 150 megapascal. So our design is safe. Then last, we have to find all other parameters using these conditions. That is b is equal to, it is already given in the data book, page number 251. If we substitute all these equations and substitute all the values of d in here, we will get b, c, f, t1, t2, t3 and a. Okay, thank you.